In this video, we're going to talk about two properties of functions. We're going to start with the turning points, give you a definition, and talk about the different types of turning points. And then we're going to talk about how to describe where a graph is increasing and decreasing. To start out, let's look at the turning points. Sometimes the turning points are called extrema. That comes from the word extreme, right? So these are sort of points at an extreme. And the definition is a turning point, basically it's where a graph makes a turn, okay? But in order to count as a turn, it's going to be the point where the graph changes from increasing to decreasing, so going up to going down, or vice versa, from going down to going up. There's two major types of turning points. You could have a maximum. So the maximum would sort of be like the point at the top of the hill, and at that point we have a y value that's higher than the y values of any surrounding point. So it's called a maximum. We could also have a minimum. That would be the point at the bottom of the valley, right? And so because it's at the bottom, the y value of that point would be lower than the y values of any points surrounding it. Of maximums and minimums, we can have two types of each. So we could have a local maximum. That means that within a section of the graph, we have a point sort of at the top of the hill. It may not be the highest point over the whole graph, but in that general area, it is the highest. Compare that with the absolute maximum. This would be the maximum point over the whole graph. This is the highest point of the whole graph. Now sometimes we have an absolute maximum and sometimes we don't. If a graph goes to infinity, or positive infinity, then we won't have a highest point, and so we may or may not have an absolute maximum. The same can be said for the minimum. We could have a local minimum, which would be a minimum over a section of the graph, sort of a point at the bottom of a valley. That point may not be the lowest point on the whole graph, but within that section it is a low point. And compare that with an absolute minimum, which would be the lowest point on the whole entire graph. Okay, so I think an example of a graph shape that could give you an idea of how this works. Let's just suppose we had a graph shape that looked sort of like this. Can you see the turning points in this shape? There should be three turning points. We have a turning point here, we have a turning point here, and we have a turning point here. So let's take a second and classify these. Let's start with this one. So I guess the first of all, is this a maximum or minimum? Hopefully that's obvious for you. This is a minimum. And then the question becomes, is this a local minimum or an absolute minimum? It's a minimum because it's a low point in this valley here on the graph. However, on the right hand side, there are points that are lower than this point. It is not the lowest point on the graph. For that reason, it is a local minimum. Okay, now let's take the one in the middle here. This point is at the top of the hill, so it is a maximum. Although it is the highest point in this little area, there are points at the ends of the graph, notice the arrows, that are higher than this point. So it is not the highest point on the whole graph. For that reason, it is a local maximum. Okay, then last one. This is at the bottom of a valley, so it is a minimum. And if you look at this shape, this is the lowest point on this whole graph shape, right? It's the lowest. There aren't any pieces of the graph below this point. So for that reason, this is an absolute minimum. Okay, so I hope we're going to take some time at the end of the semester to look at functions that have graphs like this and take time to find the coordinates of the maximums and minimums. At this point, we just want to be able to talk about them, right? How many turning points does this graph have? And is it a maximum or minimum? Is it a local turning point or an absolute turning point? Okay, so hopefully that gives you a basic idea of turning points. Now let's take a second to look at how we talk about when and where a graph is increasing, decreasing, or constant. Okay, and so the increasing, decreasing, or constant, we always make this judgment as we look from left to right. So as the x value is going up. What is going on with the y value? Is the y value going up? Also, that would be increasing. Is the y value going down? That would be decreasing. And if the y value is staying the same, then we say that that is a place where the graph is constant. It has the same y value for a section of the graph. I think this is a pretty intuitive idea. The part that I think is a little bit of a hang-up sometimes for students is the fact that we are going to describe these areas of the graph by using the x values. So even though we're tracking the y value going up and down, we're going to describe it by saying it's this section of the graph between this x value and this x value, and we're going to use interval notation to do that. So I want to give you a couple examples to try that out on. Okay, so let's start with the parabola. So here's y equals x squared. Hopefully you can see that half of this graph, as we look from left to right, half of it is going up and half of it is going down. Okay, and always the places where we make a change from increasing to decreasing or to being constant, the point in the middle is the turning point. Can you see the turning point on this graph? The turning point is here at 0, 0. So at x equals 0, the graph makes a change, and that divides it up into these categories. I'm trying to see if I can fit everything on the page. Okay, so where is the graph increasing? As we look from left to right, which half of this graph is going up? I would say that is the right-hand side of this graph. Right? On the right-hand side, as the x value gets bigger, the y value gets bigger. So if I want to describe that in interval notation, I'm going to start with 0. That's where the right-hand side of this graph begins. And as I move to the right, I can see the y values getting higher and higher and higher. And there's an arrow, so it's going to continue that pattern until infinity. Okay, and we're going to use interval notation. So from 0 to infinity, the graph is increasing. In this interval notation, it really doesn't matter whether you include the turning point or not. In all honesty, I should have checked. I'm not sure what your book does. So it's your choice. You have the freedom here. I'm going to go ahead and use the round parentheses today. Okay, because that one point is not what we're talking about. We're talking about in between points. From point to point, the y value is going up. So one particular point, there's no change being made. It doesn't really matter whether you include the 0 or not. Okay, on the other side of this graph, I think you can see that the y value is going down as we go from left to right. And so the place on the graph where this happens. It happens all the way on the left from negative infinity. The graph is way up high. And as we get closer and closer to 0, the y value is going down and getting closer to 0. So it's decreasing on the interval from negative infinity up to 0. And the same thing applies here. You could use the square bracket or the parentheses. It doesn't really matter whether you include the point in the middle, the turning point. I'm going to choose to use the parentheses today. Okay. So I want to show you another example, but the main idea here is that we're describing where it's increasing and decreasing using the x values and using interval notation. That's the big takeaway I hope that you'll get. Let's try another example. Here's another graph. This is the function y equals negative 2x cubed plus 6x squared. There are two turning points that I've sort of drawn to your attention here. This one at the bottom is the point 0, 0. And then this point up here at the top is the point 2, 8. I've got an interesting scale here, so the x-axis is marked off in increments of a half. Okay, and the y-axis, I guess is just in intervals of 1. Alright, so this would be 8 up here. Okay, so the question is, where is this graph increasing and decreasing? Same idea, we want to describe it in terms of the x values using interval notation. Let's start with increasing. As we look from left to right, where is the graph going up? I hope you can see that the middle section here is where the graph is increasing. It's going up. So as far as interval notation, we're starting at the place where x is 0. And in between 0 and all the way through here up to the x value of 2, the y values are going up. So when I talk about where it's increasing, I'm going to say this is increasing from 0 to 2. Please understand this is not a point, which is a common misconception. This is an interval from 0 to 2. Okay, then we want to talk about where is it decreasing. I'll tell you what, I made a mistake here and left off the arrows for this graph. There should be arrows at the end, so I'll pencil those in right now. Alright, so where is it decreasing from left to right? Two places. This branch here on the left is decreasing. So just like the last example, all the way off to negative infinity, this graph is going to be going down and down, down until we get to 0, 0. So from negative infinity up to 0. And there is a second place on the right here. It is going down after we pass the turning point at 2. We are going down as we continue to the right, and because of the arrow, we're going to continue going down as x goes to infinity. So we're starting at 2 and going to infinity. And anytime we're describing a set of numbers and those numbers happen in two places or more, we're going to use that union in the middle, and so that would apply here as well. I hope that gives you a good idea of what it's like to talk about where a graph is increasing and decreasing. And the big point I hope you caught here is that we're using the x values and we're using interval notation to describe that. Good luck with this idea. We'll see you in the next video.